The process for deploying a cluster from the Rancher UI is intuitive. Actually, why are we even here if it's so intuitive?
To show them how intuitive it is.
Oh, that's right.
It's intuitive, but it's not obvious.
So hold on, you're going to see how intuitive this is now. If you chose a hosted provider, you'll be walked through a series of pages that begin with authentication. Makes sense, right? And after providing authentication credentials, the information presented on subsequent pages has been pulled directly from the account within the provider. So this is going to all be contextual now to your specific account and your specific cloud provider's information. Continue through the configuration pages to deploy the cluster now.
Rancher provides the ability to provision some hosted Kubernetes clusters in the Add Cluster screen. I'll choose Amazon's Elastic Kubernetes Service, or EKS, for this example. No cloud credentials are needed. I just need to give the authentication info as a part of creating the cluster. I can set many of the options for an EKS cluster through the next few steps, including Kubernetes versions supported by Rancher, network settings, and worker node sizing, and some VM details. Once I create the cluster, Rancher will reach out to Amazon to create all the needed resources. In my case, it took about 10 minutes for the cluster to register as waiting. Rancher will eventually gain access to the EKS cluster's API server, meaning management of Kubernetes API resources for RBAC and tooling and even workloads can now begin. Amazon manages the control plane, so we can only see worker nodes listed when inspecting the nodes section of this cluster.
Clusters that are deployed in an infrastructure provider utilize node templates and can also use RKE templates.
I want to have Rancher create VMs for me and also install Kubernetes on these nodes. That means I need to use a node driver. As covered before, using a node driver to provision a cluster requires a cloud credential and node template for the target environment. I'll configure a more resilient cluster architecture. 3 masters that have the combined role of etcd and control plane gives 1 node of fault tolerance due to the requirements of etcd. I'll use 2 workers to help distribute the workloads in this small cluster and possibly give enough overhead to allow a node to fail while keeping a minimum required capacity. Once I create the cluster, Rancher will create the master nodes first to bootstrap the actual Kubernetes cluster data store and API server. Without these, well, a cluster doesn't even exist. The workers will be added after the bootstrapping phase to provide capacity for the intended workloads. Once all nodes are created, configured, and added to the cluster, we'll see a healthy node driver cluster in the UI.
When you provision a cluster with an infrastructure provider, Rancher first stands up the infrastructure and then builds an RKE cluster on it. A custom cluster is literally the second part of that process. You'll use a custom cluster when you're provisioning infrastructure via any other means, including on bare metal. The only requirement for a custom cluster is that the host has a supported version of Docker installed. Rancher, conveniently, provides an easy installation script that you can use on any host to make sure that you're using the correct, unmodified, upstream version of Docker. Each version of Rancher is tested with specific versions of Docker and Kubernetes, including RKE, hosted Kubernetes, and imported clusters launched externally. The details of these tests are available in the Rancher Labs support matrix page of the documentation, specifically under the tabbed version list about halfway down the page. You're free to install Docker via any means, but we find that the best experience comes from using upstream Docker. To make this installation easier for you on any Linux flavor, Rancher provides an install script. This script will detect the Linux distribution and perform all of the necessary steps to install a non-modified version of upstream Docker. You can include this in your provisioning system, and if you're uncomfortable piping downloads to a shell, you can simply save the file, make it executable, and then execute it in a subsequent command. The script will install the latest patch version for a specific minor release, so if you want to install a different version of Docker, just change the last part of the URL. For example, instead of installing 1809, I could have installed 1806 or 1903. The custom install command that Rancher provides is unique to the cluster that you're creating. You can add it to your external provisioner, and when you scale up nodes with the provisioner, those nodes will automatically join the cluster. It's magic.
Like super magic or just regular magic?
Super magic.
That's better.
To maintain full control over the infrastructure supporting a Kubernetes cluster, yet leave the installation of Kubernetes components to Rancher, I'll choose to create a custom cluster. I'd only need to set up any Kubernetes options, as Rancher has no control over any nodes in this situation. Once I proceed, I'll see a Docker command to run on nodes I want to add to this cluster. I'll copy the command for a node that has a combined role of etcd and control plane. Specifically, this will start an agent on the node to communicate with the Rancher server, add the node to the cluster, and receive commands to install the necessary Kubernetes components. Since I've copied this command, I'll SSH into my first node where Docker is installed, paste the command, and run the agent container with the given arguments. As soon as the agent reaches the Rancher server, we see a node has been registered in this cluster. I'm performing all these steps by hand, and I've chosen to have 3 master nodes, so I'll have to SSH into the remaining VMs to run this command. Here's sped up proof, I actually did that. Now we see all 3 nodes have been registered, and while I'm here, I'll copy the command for a worker node. When I list the nodes that exist, we see 3 in-progress master nodes. I need to perform a similar process for my 2 worker nodes. Note that it's recommended to use a configuration management solution or possibly cloud init to automatically run these commands. The registration command can be fetched from Rancher through its API, meaning any integration that can make HTTP calls could create and fully manage a custom cluster as long as proper access is granted. Now that I've wrapped up adding all nodes, I can let Rancher finish the Kubernetes installation process. After a bit, you may see an active but an unhealthy cluster. If everything goes well, the cluster will converge to a fully healthy status.
Rancher supports Kubernetes on Windows and treats Windows workers as first-class citizens.
That's not normal.
It's a brave new world we live in. Welcome to 2020, Adrian.
Well, but most support for Kubernetes on Windows actually expects that you will be by default deploying Linux workloads, whereas when Rancher deploys a Windows cluster, it expects that you'll be using Windows workloads by default.
It's a great point. We really try to make Windows a first-class citizen because we see that is a need in the industry. So how this works is very simple. When deploying a cluster with Windows workers, you first have to deploy a Linux control plane because this is required by Kubernetes, and one Linux worker to host the ingress controller, because that's a Linux-only function. Kubernetes on Windows works currently with a flannel CNI, and once you choose this option, you can enable Windows support.
Rancher's Windows support is limited to custom clusters leveraging Windows worker nodes. When I create a custom cluster, I can see that Windows support can only be enabled as of Kubernetes 1.15 using the flannel network provider. These limitations only exist because many system-level components were initially built to only support Linux. When Windows support is enabled, I can configure Windows-specific network options. Then, I can proceed to note down the commands needed to register nodes for each operating system. Again, etcd and control plane nodes must run on Linux, while the Windows command is locked to the worker role. As expected, you can run the Windows command to register a Windows server as a worker.
If you want to manage an existing cluster with Rancher, then you can just import it. This option gives you a kubectl apply command that you can run against the existing cluster. It will pull its information from the Rancher server and install the agents that allow Rancher to manage the cluster. Rancher provides 2 versions of the command. One is for a Rancher installation that uses real certificates. The other is for a Rancher installation that uses a certificate signed by an unknown CA. kubectl won't connect to this type of endpoint, so you have to pull the manifest with curl and then pipe it to kubectl.
Sounds a little complicated.
It's better than not being able to do it at all.
It's true.
It's just the way that it is. If you're using a self-signed cert from a private CA, just use curl and pipe it to kubectl and you'll be fine.
Say I've installed and created a Kubernetes cluster on my own, but still want to manage it through Rancher. I'll need to create an imported cluster, give it a name, then run the provided kubectl command against the target cluster to install Rancher's agent components. I've created a K3s cluster for this example, so I'll set my kubeconfig as the one pointing to this installation. When I run the kubecontrol command, I see all the needed RBAC and workloads are created to perform the import. When I move back into the Rancher server and inspect the nodes, this time without needing any fast forwarding, I see the single node in this cluster appear. Once the API server is confirmed to be healthy, I can begin managing this cluster through Rancher.